Happy morning, children. Today we learn the family of numbers. We know that counting numbers are natural numbers, and if we include 0 to that family, we call them as whole numbers. And if we add negative numbers to that family, we call them as integers. The collection of whole numbers and negative of natural numbers are called integers. 1, 2, 3 are positive numbers. They are counting numbers. -1, -2, -3 and so on are negative numbers. 0 is neither positive nor negative. On the number line we represent natural numbers like this and whole numbers like this. Here this arrow mark indicates natural numbers are infinite, endless. Whenever you say that this is the largest number, there is always another next number you will get. Same with the whole numbers. And we call them as integers when we add negative numbers to the family. And these integers are indicated on the number line like this. This point is denoted as 0. We can represent 0 on one point on the number line, where this number line is infinitely extended towards right and towards left. When it is extended towards right, we get positive numbers. When it is extended towards left, we get negative numbers. And 0 is neither negative nor positive. And absolute value of an integer is its numerical value regardless of its signs. For example, absolute value of -2 is 2. Next we study the family of rational numbers. When we say that I have 1 rupee and half rupee, I have eaten 1.5 rotis. So here half is what? Is a fraction, part of a whole. We define rational numbers as the number that can be written in the form p by q, where p and q are integers and q not equal to 0, is called a rational number. Why this q not equal to 0 is mentioned? Because when we divide any number by 0, it is not defined. Therefore, this condition is mentioned. In the rational number p by q, p is called the numerator and q is the denominator, as we call in fraction. But fractions are always positive. But rational numbers contain integers. All integers are rational numbers. Because 2 can be written as 2 by 1. 3 can be written as 3 by 1. -2 can be written as -2 by 1. So all integers are rational numbers like this. 2 by 3 is a rational number. 4 by 5, 7 by 9, 11 by -8. 3, as I said, 3 is a rational number because it can be written as 3 by 1 and is equal to 3 only. And 0 by 1, anything we write 0 by 1 is 0 only. That is, if 0 is divided by any number, you will get 0 only. Then -6 can be written as -6 upon 1. So all integers are rational numbers, etc. are all rational numbers. Now we study what are positive rational numbers, because we defined a rational number as the number of the form p by q, where p and q are integers. It means p can be negative or positive, q can be negative or positive. So what are positive rational numbers? If both the numerator and the denominator of a rational number are positive or negative, then the rational number is said to be positive. For example, 6 by 5. Here the numerator 6 is positive and denominator 5 is positive. So this number is a positive rational number, whereas minus 4 divided by minus 7 is equal to 4 by 7. Why? When we divide a negative number by a negative number, we get as positive number. Therefore, it is a positive rational number. If both the numerator and denominator are having negative sign, then that number is a positive rational number. 0 by 6, 8 by 1, etc. And what about negative rational numbers? If either the numerator or the denominator is negative, then the rational number is said to be negative. For example, minus 7 divided by 13 is minus of 7 by 13. And 4 divided by minus 9 is equal to minus of 4 divided by 9. In this first number, the numerator is negative, therefore the whole rational number is negative. In this second number, denominator is negative, therefore the whole rational number is a negative rational number. This is how we understand the sign of the rational number. Now, let us study about equivalent rational numbers. When the numerator and denominator of a rational number is multiplied by the same non-zero integer, we get an equivalent rational number. A rational number has infinite equivalent rational numbers. For example, 3 by 5. If you multiply the numerator and the denominator by the same number 2, we get 6 by 10. We say that 6 by 10 is the equivalent fraction of 3 by 5, or because it is positive, I say that it's a fraction. It is a rational number. 6 by 10 is the equivalent rational number of 3 by 5. And if you multiply 3 by 5 by 3, numerator by 3 and denominator by 3, then we get 9 upon 15 as its equivalent rational number, and so on. The numerators 3 by 10, 6 by 10, the numbers 3 by 5, 6 by 10, 9 by 15, 12 by 20 are equivalent rational number. So, if we go on multiplying the numerator and denominator by the same non-zero integer, then we will get the equivalent fractions or rational numbers. Here, rational number has infinite equivalent rational numbers. Okay. Then, simplest or standard form of a rational number. The numerator and denominator are co-prime. When we say a rational number is in its simplest form or standard form or lowest form, if the numerator and denominator are co-primes, that is, one is the only common factor between them, and there is one more condition. The denominator is always a positive integer and the negative sign, if any, occurs only in the numerator. Here, while we studying the negative rational numbers, here I explained that 4 divided by minus 9 is a negative rational number, but this is not in the standard form. It should be written like this, or negative sign is assigned to 4. For example, the simplest form of 15 by 20 is 3 by 4. P by minus Q is written as minus P by Q, or simply minus of P by Q. Okay. That is 2 by minus 3 is written as minus 2 by 3. Minus 5 divided by minus 8 is 5 by 8. Now, how we compare the rational numbers? Comparison of rational numbers. Any positive rational number is greater than any negative rational number. 1 by 2 is greater than minus 3 by 4. However big the numerator and the denominator be, or however big the rational number B, if it is negative, then it is always smaller than the positive rational number. 0 is less than any positive rational number and greater than any negative number. We have seen in the number line. Okay. Minus 3 by 4 is less than 0 is less than 3 by 4. And minus 1 by 2 is less than 0 is less than 9. Rational numbers are compared as we compare fractions. If the denominators are same, greater the numerator, greater the rational number. Smaller the numerator, smaller the rational number. And if the numerators are same, then greater the denominator, smaller the fraction. Here 4 is greater than 3, but 1 by 4 is smaller than 1 by 3. And 2 by 3 is equal to 10 by 15 is less than 4 by 5 is equal to 12 by 15. Here we find the equivalent rational numbers of the given numbers and then compare. How do we find the equivalent rational numbers? Earlier we studied by multiplying the numerator and denominator to make the denominator same. Negative rational numbers are compared ignoring the negative sign, then by reversing the order of the fractions. Here 2 by 3 is less than 4 by 5, but minus 4 by 5 is less than minus 2 by 3. Here, if the negative sign is assigned to the rational number, then that will be smaller than the other number. Representation of rational numbers on a number line. How do we represent on the number line? Always we know that rational numbers are fractions, but in fractions all the numerator and denominators are positive, but in rational numbers numerator can be negative or denominator can be negative, or both the numbers can be negative. On the number line we we represent the numbers like this. 1 by 5 is a part of a whole between 0 and 1, and 1 and half, that is 3 by 2, is greater than 1 and smaller than 2. Therefore it comes between 1 and 2. We make equal parts among the whole part and we represent that number on the number line. Okay. If you have any doubt, you please feel free to send the message so that I will clear that. Next, we study properties of rational numbers. First one is closure property. For any two rational numbers a and b, a plus b is also a rational number. Hence, rational numbers are closed under addition. For example, 2 plus 3 is equal to 5 and minus 2 plus 3 is equal to 1. 2 minus 3 is equal to minus 1. All these numbers are rational numbers. Therefore, we say that closed under addition. For any two rational numbers a and b, a minus b is also a rational number. Hence, rational numbers are closed under subtraction. For any two rational numbers, a into b is also a rational number. Hence, rational numbers are closed under multiplication. For any two rational numbers a and b, a divided by is not always a rational number. Because if you divide any number by 0, it is not defined. Therefore, we say that rational numbers are not closed under division. Next property is commutative property. For any two rational numbers a and b, a plus b is equal to b plus a. Therefore, rational numbers are commutative under addition. That is, if we change the order of the numbers, then the sum will be the same. This is called the commutative property. For any two rational numbers a and b, a minus b is not equal to b minus a. Therefore, rational numbers are not commutative under subtraction. For any two rational numbers a and b, a into b is equal to b into a. Therefore, rational numbers are commutative under multiplication. For any two rational numbers a and b, a divided b is not always equal to b divided by a. Therefore, rational numbers are not commutative under division. And next, associative property holds good for addition and multiplication of rational numbers but does not hold true for subtraction and division. That is, for any a comma b comma c belonging to q means what? For any rational numbers a comma b comma c, a plus in bracket b plus c is equal to in bracket a plus b then plus c. If we change the order of the numbers, the sum will remains the same. Similarly, if we change the order of the numbers, the product will remain the same. Whereas subtraction is not holding good for associative property, because when we subtract numbers, the difference is not equal and the quotient is also not equal. Therefore, associative property does not hold true for subtraction and division. Then what is distributive property? I call this as a chocolate property because when we distribute chocolates to children, we see that each child will get a chocolate. Like that, this multiplication sign is a chocolate. We distribute this chocolate to these two children. That is a into bracket b plus c is equal to a into b plus a into c. That is a is multiplied by b and then this product is added to a multiplied by c. Distributive property of multiplication over subtraction. Similarly, we can say that for all rational numbers a, b and c, a into bracket b minus c is equal to a into b minus a into c. Now we will study operations on numbers. We have learnt that the integers are also rational numbers. Therefore, the rules that govern the operations on integers are extended to the operations on rational numbers. We also know that all the rational numbers are having numerator and denominator. So, how we add rational numbers? To add rational numbers, first express them in standard form. Adding rational numbers having same denominator. The first case is numbers with same denominator. If the denominators are same, simply we add or subtract the numerators and write the sum or difference as the numerator and the common denominator as the denominator of the sum or difference. See here, minus 3 by 8 plus 5 by 8 is equal to minus 3 plus 5 divided by 8. It is 2 by 8. And in the simplified form, it is 1 by 4 because 2 ones are, 2 fours are. 2 is the HCF of 2 and 8. When we divide both the numerators and denominators by the HCF, their HCF, we get them in the simplest form. Similarly, 1 by 2 plus 3 by 2 is 1 plus 3 upon 2. This is 4 upon 2 because 1 plus 3 is 4 and 4 upon 2 we get as 2 because 2 ones are, 2 twos are. Now adding rational numbers having different denominators. This is the second case. When the denominators are not same, what will you do? We will take the LCM of the denominators. Then we write the equivalent fractions, making the denominator is equal to LCM, making LCM as its denominator. That is 3 fours are 12. So multiply numerator also by 4. Here 4 threes are 12. So multiply numerator also by 3. So that we will get the denominator as a 12 and accordingly the numerator is also changed. 4 twos are 8, 3 threes are 9. Now we have the rational numbers with the same denominator. Add the numerators and get the sum. Similarly, subtraction is done. Here, subtraction of rational numbers. Subtract minus 2 by 3 from 5 by 9. 5 by 9 minus of minus 2 by 3. because we should write it in the bracket because it is a negative rational number. When the negative rational number is subtracted, then the sign will change. Here 9 and 3 are the denominators and the LCM of 9 and 3 is 9 because 9 is the multiple of 3, and if two numbers one is the multiple of the other, then the larger number is the LCM. Here we have to multiply the numerator by 1. You have to multiply the numerator by 3 because 3 3s are 9. Then it is 5 by 9 minus of minus 6 by 9. And if you open the bracket, minus into minus will be plus. 5 plus 6 upon 9. It is 11 upon 9. This is how we add or subtract the rational numbers. Now the multiplication of rational numbers. How we multiply rational numbers? Like how we multiplied the fractions. Here signs are considered. Product of numbers is equal to product of numerators divided by product of denominators. Multiply minus 6 by 5 and 15 by 24. Here cancellation is allowed because these two are the factors of this product. Means when we multiply two numbers, we get the product. We can cancel 5 and 15 because 5 ones are 5 threes are. Here 6 and 24. 6 ones are 6 24. 6 fours are 24. So because the minus sign is here, we should write minus as it is. Then 3 as it is. Then 1 and 4 as it is in the place of denominators. Multiplying the numerators, minus 1 into 3 we get minus 3. Divided by 1 into 4 we get 4. Therefore the product of these two rational numbers is minus 3 by 4. We should not ignore the negative sign. In Kannada we say mana illadire avamana. Now division of rational numbers. We divide any rational number by any rational number, other rational number. While doing so, we change the operation and we write the reciprocal of the divisor. Here this is dividend and this is the divisor. Right? And this divisor and the dividend are in the mixed fraction form. We will convert them into improper fraction form. Then we multiply or divide. Here 5 integer 1 by 2 is written as 11 by 2 because 2 5s are 10 plus 1 is 11, 11 by 2. 7 4 7s are 28 plus 1, 29 by 4. Because of the minus sign, we should put the minus sign as it is. Then dividend is 11 by 2 and minus 29 by 4 is the divisor. We have to write the reciprocal of the divisor and change the operation to multiplication. Then as per the multiplication rules, we multiply these two numbers and we get minus 22 upon 29 because 2 and 4 can be divided, cancelled and written as 1 and 2 as the quotient. 11 into 2 is 22, 1 into 29 is 29. Okay, this is the quotient. Then the rational number 0 is the additive identity for rational numbers. The rational number 1 is the multiplicative identity for rational numbers. The additive inverse of the rational number a by b is minus a by b and vice versa. Here simply change the sign of the given rational numbers to get the additive inverse. And reciprocal or multiplicative inverse of the rational number a by b is b by a and vice versa. Here simply write the reciprocal of the number. Don't go to change the sign of the rational number. Here for additive inverse you have to change the sign, but for the multiplicative inverse simply write the reciprocal without disturbing the sign of the rational number. Rational number plus its additive inverse is 0 and rational number into its reciprocal is 1. When the sum of two numbers is 0, then each number is said to be the additive inverse of the other. Here 2 plus of minus 2 is equal to 0. Therefore we say that 2 is the additive inverse of minus 2, or minus 2 is the additive inverse of 2. When the product of two numbers is 1, then each number is the multiplicative inverse of the other. 2 into 1 by 2 is equal to 1. Here 1 by 2 is the reciprocal of 2. When we multiply these two numbers, we get 1. That is the multiplicative identity. Okay, you will understand this concept more when we solve examples. Okay, we will continue in the next video.